Hello friends, welcome to GeoEdu channel exploring geological knowledge. Today we will discuss about introduction to silicate melt and nature of magma. What is magma? The original molten rock material is conveniently termed as magma. Magma is the term first introduced into geological knowledge, geological literature by Scope in 1825. According to Scope, magma is a compound liquid consisting of solid particles suspended in liquid like mud. Lava is the magma that finds its way to Earth's surface. Then silicate melt. Silicate minerals have highly ordered atomic structure consisting of an oxygen framework in which the cations sit in two major type of sites, that is tetrahedral sites and octahedral sites, contain silicon and aluminum. Depending on the mineral, they may occur as isolated tetrahedral and as well as linked tetrahedral. The octahedral sites lie elsewhere in silicate structure and bond various tetrahedral bonded polymers together. Cations typically found in octahedral site are iron, magnesium, calcium and sodium. Then we'll discuss about network forming ions and network modifying ions. When a silicate minerals melt, the long range atomic order disappears, but the short range order will maintained. So the octahedral and tetrahedral sites remain in the melt, but the polymers formed from the interlocked silica tetrahedra are discontinuous. So the smaller ions, primarily silicon, aluminum, phosphorus, are called as network forming ions because they occupy the tetrahedral sites and help to polymerize the melt. In contrast, the larger ions, that is iron, magnesium, calcium, sodium, are referred to as network modifying ions because their presence tend to depolymerize the melt. For example, granites are rich in network forming ions like silicon and aluminum, hence have high degree of polymerization, which makes the granitic melts more viscous. Whereas the basaltic melt consist of more network modifying ions like iron and magnesium, which makes it more fluidous. Magma occurs in three phases. First, solid, liquid, and gases. It can also occur in individually, like it can occur as only solid phase, solid and liquid phase, solid and gaseous phase, and all three phases also coexist in a same magma. Composition of magma. Mostly it composed of 9 elements, that is oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium. It make up these 9 elements makes up around 99%, 99.25% of the whole magma. And volatiles are hydrogen, fluorine, chlorine, sulfur and other compounds. Also plays important roles. There are three important type of magma, that is basaltic magma, andesitic magma and rhyolitic magma. Basaltic magmas are rich in iron and magnesium, and its temperature ranges from 1000 degree centigrade to 1200 degree centigrade. Andesite magma are moderate in iron, magnesium as well as calcium, potassium and sodium, and its temperature ranges from 800 degree centigrade to 1000 degree centigrade. The rhyolitic magma is high in potassium and sodium but low in iron and magnesium, and its temperature ranges from 650 degree centigrade to 800 degree centigrade. What is pyrogenetic minerals? If we will break the term, we will find two terms, that is pyro, which means fire, and genetic, which means origin. So the minerals directly formed from magma is known as pyrogenetic minerals. And since oxygen and silicon are the most abundant elements in magma, so silicates are the chief pyrogenetic minerals. Silicon is capable of forming several acids like orthosilicic acid, metasilicic acid, polysilicic acid. Hence, pyrogenetic minerals falls into all these three acids. Potassium and sodium are the most active bases present in igneous magma, and calcium is less, and magnesium and iron is weakest. Hence, highest amount of silica is bounded in polysilicates like olivine and albite. Iron is the weakest affinity, hence affinity for silica, hence appear as oxides. So we can find iron as mostly as oxides like hematite and magnetite, and very less amount iron is attached with silicon. This is a simple formula like mineral of low silication plus silica is equal to mineral of high silication, and minerals of low silication are leucite, nephrine, analcite, olivine, and biotite. Minerals of high silication are orthoclase, albite, anorthoclase, orthopyroxene, augite, azerine, and hornblende. There are 14 molecules which are principal components of magma given by Nagli. These are chalcophyllite, nepheline, testmass molecule, mica, sodium silicate, potassium silicate, calcium silicate, phyllite, phosphorite, quartz, water, oxygen, magnetite, and spinel. The pyrogenetic minerals formed either individually from the above molecule or by additive reactions. Feldspars form, for example, feldspar form from the combination of chalcophyllite, nepheline, testmass molecule, and silica. Magma of given composition may give rise to more than one set of minerals under different conditions. This phenomena is termed as heteromorphism, and the products are heteromorphous. For example, a mixture of orthoclase and biotite have same ball composition as the mixture of leucite and olivine. Former mixture crystallizes at low temperature and high pressure, hence is a plutonic rock, that is mica cyanide, whereas the latter is volcanic rock, crystallizes at high temperature and low pressure, is a volcanic rock, that is leucite basalt. Then volatile fluids that present in magma, and what are their roles? The most important fluids are water, carbon dioxide, hydrogen, HCl, N2, HF, AFCl, SO2, H2S, CO, CH4, O2, NH3, H2, and other noble gases. And most volatiles consist of only 6 low atomic weight elements, that is hydrogen, carbon, oxygen, sulfur, chlorine, and fluorine, not silicon. I'm sorry. Oxygen is the most abundant ion in the magma, and then another important term comes into the picture, that is critical point. So gaseous vapors, there is a point where there is no distinction between gases and liquid. This point is known as critical point. This occurs at high depth. Thus, at high depth more than 1 kilometer, there is no distinction between gas and liquid. So the term fluid is used for the density of 2 gram per centimeter cube and volume of less than 0.5 centimeter cube per gram. The fluid pressure also plays important role in magmatic fluid. The bulk fluid pressure can be measured by fluid pressure of water and fluid pressure of carbon dioxide and the other constituents like that. Then what is the role of water in magmatic liquid? Water reacts with bridging oxygen to break the silicate network. As you can see in the picture, the addition of water tends to break the silicate network into silicon and hydroxyl ion. Addition of water also decreases the viscosity of magma. Addition of water also decreases the temperature of crystallization. This is the this curve is albite liquid curve, which clearly explains what the relation between water pressure and as the water pressure is increasing, as the water pressure with the increasing in water pressure will cause the melting progressively lower temperature. So the melting temperature decreases with the addition of water. Then role of carbon dioxide. Carbon dioxide, as like water, also plays very important role, and The addition of carbon dioxide affect the viscosity of magma. Carbon dioxide dissolves into the melt, and the following reactions takes place. That is, as we see in the picture, carbon that's SiO2 plus CO2 is equal to, it is giving rise to silicon, and carbon dioxide. So carbon dioxide has a greater solubility in melt and with low polymorphism such as basalt, because in case of high polymorphism melt such as albite granite, the availability of non-breaching oxygen may leads to form the bond with carbon dioxide. This The effect of carbon dioxide on melting temperature of silicate rock is far less extreme than that of water, because carbon dioxide uh, has much lower solubility than water. Carbon dioxide is most soluble in basaltic melt at high pressure, and this means that the basaltic melt rises in the crust, it will exhale carbon dioxide. And to will continue further. Thanks for attention. Subscribe to my channel GeoEdu Exploring Geological Knowledge. Thank you.